Hi, welcome to today's session on finding the quadratic M-term rule. So, very similar to when we are trying to find an M-term rule. We are going to use this to find a quadratic M-term rule. So it's very similar, but there are extra steps that we need to take. So here I've got a sequence of -2, 1, 6, 13, 22, and obviously this will continue. And above it, I've just gone and written their position within the sequence. So my first, second, third, fourth, and fifth term. Just the same as when we are trying to calculate the M-term rule of a linear sequence, I'm starting off by looking at my difference. Now, as you can see, to get from -2 to 1, I add 3. Next one, add 5, add 7, add 9. It's not a constant arithmetic addition or subtraction to get from each term. So I know I'm not going to have just a straightforward maybe a 2n plus 1 or anything like that. It is going to actually involve maybe a quadratic. Now, because this isn't constant, I'm actually going to now look for the difference of my difference. I'm going to look at how do I get from my 3 to my 5, my 5 to my 7, my 7 to my 9. Now, as you can see, each one of these, I add 2 each time. I've now got a constant difference, but it's a constant difference of my difference. Now, because it's adding 2 each time, I'm now going to halve my difference and put this in front of an n squared. Because half of 2 is 1, I just haven't wrote in my number 1, and I've just left it as n squared. Now, much the same as what I did with my linear M term, I'm now going to do my n squared times table. I'm going to replace each time my letter n with my position term I'm looking for. So 1, 4, 9, 16, 25. And I'm going to look at how do I get from my newly created sequence to my original sequence. And each time it's constant for each one, and it is -3. So I literally add this to the end, so it's n squared minus 3. So that is my quadratic M-term rule. Just testing now by looking at my fourth term, which is 13, just to see if it works. And if I was to now substitute in 4 for my n, 4 squared is 16, minus 3, that certainly does give me 13. So I know that this quadratic M-term rule is working. I could use it to maybe find the 50th term in my sequence. If I was asked what number term was in, what number value would be underneath this position, and if I was to substitute 50 into my quadratic M-term rule, underneath my 50th term would be 2,497. Now, they could get a bit more complicated. They could get a bit more involved. In which case, here I've got a different sequence of 3, 5, 9, 15, and 23. Now, as you can see each time, it's not a constant addition. I've got 2, then I'm adding 4, then I'm adding 6, then I'm adding 8. In which case, very similar to what we did in the step beforehand, we're now going to look at the difference of our difference. Our difference of our difference is constant, plus 2. So again, we're going to halve this and put this in front of the n squared. So again, half of 2 is 1, so I haven't wrote my 1 in front of the n squared. And I'm going to do my n squared times table. 1, 4, 9, 16, 25. But again, I'm going to look at how do I get from my newly created M sequence to my original sequence. But as you can see from this, it's not constant each time. It's ever changing. So to get from my 1 to my 3, I'm adding 2. To get from my 4 to my 5, I'm adding 1. 9 to 9, not doing anything. 16 to 15, minusing 1. 25 to 23, I'm subtracting 2. Now, This is part that normally throws learners. I'm now actually going to take my difference of my newly created sequence to my original, and I'm going to create its own sequence. I'm just going to write it to one side and create its own sequence. In which case, as you can see, each time I've got a constant difference between my terms. My sequence is going down by 1 each time. So I'm going to write this as minus n. Just the same as what I would do in if I'm dealing with linear nth term. I'm just looking for the difference between, because it's constant, it's my my number that's going up or down by is just going in front of n. So because it's a negative 1, it's negative n. And I've just put this after my n squared. So it's become n squared minus n. Now I'm going to substitute my value each time for my position into my n squared minus n. So 1 squared minus 1, that gives me 0, and so on and so forth. So I've got 0, 2, 6, 12, and 20. Now my newly created sequence, I'm now going to see if there's a constant difference between this and my original sequence. As you can see, to get from 0 to 3, I add 3. From 2 to 5, I add 3. And it's the same for the rest. I found a constant difference, in which case, because I'm adding 3 each time from my newly created sequence to get to my original sequence, I'm just putting add 3 onto the end. So my n term rule for this will be n squared minus n plus 3. Now, it's not always going to be n squared. We could actually end up with a number in front of the n squared, a multiple, or being technical, a coefficient. So here I've got a new sequence, minus 1, 5, 15, 29, 47. Again, going to look at the difference between my terms. And as we can see, it's not constant, 6, 10, 14, 18. Now, looking at the difference of my difference, it is adding 4 each and every time. So again, exactly the same as what we did with the previous 2 examples. We're taking our 4 and we are halving this. Half of 4 is 2, and that 2 goes in front of my n squared. Now if I was to do my 2n squared times table, so replacing my n with 1, 1 squared is 1 times 2, that gives me 2. So I end up with 2, 8, 18, 32, and 50. Going to look at the difference between my newly created sequence and my original sequence, and it is constant each time. It's subtracting 3. So I'm going to add this to the end of my 2n squared. So my n term rule for this is 2n squared minus 3. Now, this is an idea which again throws certain learners. In which case, anytime that we're looking at the difference of our difference, we've got to remember that we've got to halve this, which becomes the number in front of our n squared. So if our constant difference is add 2, we're not going to write anything in front of our n squared. If our constant difference is 6, it's going to be 3n squared. If you like what you see, please subscribe. Thank you very much for watching.